This is our session 9 on trigonometric functions. We had done sine inverse, cos inverse. Now we'll go on to tan inverse functions. Okay, so let us begin.
So we were doing tan inverse. So let us say that we have a function tan theta is equal to x. Okay. Now first let us define the domain and range for tan theta. So that will be x should belong to R. Okay. And theta should belong to minus pi by 2 to pi by 2. Okay, these are the values in which theta should lie. So when will tan inverse exist then? For the same range and domain, tan inverse x is equal to theta is possible only if x belongs to R, okay, and theta belongs to minus pi by 2 or pi by 2 and any value between them. Okay, that is tan theta. That is the inverse function for tan. Now, what are the properties, or you can say some things that we need to remember for tan? So tan of tan inverse x, similar to sine and cos, is equal to x. So x should belong to all possible values, real numbers, and tan inverse of tan y, okay, is equal to y, where y should belong to all the possible values of theta, that is minus pi by 2 to pi by 2. If it lies between them, then this property is true. Okay, let us go to the next one. That is cosec theta. So cosec theta is equal to x. Okay. Now, when will cosec inverse x exist? Okay. For which values, or you can say for what range? So cosec inverse x is equal to theta. When will that happen? When x belongs to, okay, cosec theta equal to x, cosec inverse x equal to theta when x belongs to R minus 1 comma 1 and theta belongs to minus pi by 2 to pi by 2 minus 0. Okay. Now we know that cosec theta is actually 1 upon sine theta, right? So if the x value is 0, that is if theta value is 0, then sine 0 is 0 and 1 upon 0 becomes infinity. And so cosec inverse of infinity is not possible, and that is why we have written theta value should not be 0. It could be anything from minus pi by 2 to pi by 2, but 0. Okay, and that is the range and domain of cosec inverse function. Okay, and again you will have the property. So cosec of cosec inverse x, okay, is equal to x, and cosec inverse of cosec x, sorry, cosec y is equal to y. Here x should belong to R, okay, R minus 1 comma 1, okay, and y should belong to theta values, that is pi by 2 minus pi by 2 to pi by 2 minus 0. Okay, so it should not include 0, it should have these values. And R minus means the infinity values are open-ended, they are excluded from cosec inverse real values, that is x belongs to R. From there the infinity values are excluded, and that is why we write it in this format. Okay, that is cosec inverse. Now let's go to the sec values. Sec theta. Yeah. So sec theta is equal to x. Okay, so sec inverse x will exist for which values of theta? Let us write. So x belongs to R minus minus 1 comma 1, again similar to cosec, and theta value should belong to 0 comma pi. Here we are dealing with 1 upon cos, right? Sec theta is 1 upon cos. So when does cos theta become 0? That is 90. So minus pi by 2. That means pi by 2 should not be included in the um, range, right? So of second verse. So second verse x equal to theta 0 comma pi minus pi by 2, because if we have pi by 2 then we'll have second verse of infinity which will not have an answer. Okay, that is why infinity value will not be included in the inverse function. Okay, now that again we'll have the properties for sec. So sec of second verse x is equal to x, where x should belong to r minus minus 1 comma 1, and second verse of sec x is sec y, same mistake, is equal to y, where y will belong to all the theta values, that is 0 comma pi up to, or you can say excluding minus pi by 2 over here. So we remove pi by 2. Okay, now the next one is cot theta. So on cot theta equal to x. Okay, so cot inverse of x is equal to theta. When will this happen? When x belongs to r and when theta belongs to 0 comma pi. Okay, so these are the values for domain and range of cot inverse of x. Then we'll have the properties as cot inverse of cot x is equal to x, okay, where x belongs to r, and cot inverse of y is equal to y, where y belongs to 0 comma pi. Okay, now we'll move on to properties of trigonometric functions, inverse trigonometric functions. So properties of inverse functions. Yes. So let us begin with the first one. I am not proving the properties over here because the proofs are easy to understand also, and they are not of that much value. You can check them out in the textbook. I'm just doing the properties and then we can go on to the numericals. Okay. Now the first one is that if x lies between minus 1 and 1 and it's not equal to 0, then we can say that sine inverse of x, okay, is equal to cosec inverse of 1 upon x. Okay, this is property for sine and cosec. Similarly, we can write it for cos. So in that, cos will be cos inverse of x, okay, is equal to sec inverse of 1 upon x, okay, when x belongs to, or x lies between minus 1 and 1 and x is not equal to 0. Okay, then we can write the same for tan, but the x value will be, that is tan inverse of x is equal to cot inverse of 1 upon x, okay, when then we can say x is greater than 0, okay, but not equal to 0, and we can say that tan inverse of x is equal to minus pi plus cot inverse of 1 upon x when x is less than 0, okay, not equal to 0, less than or equal to, less than or greater than 0, okay, that is your tan function. Now let's move on to the fifth one. Okay, what's the fifth one? So we have the negative function. So if minus 1 less than x less than 1, okay, then sine inverse of minus x is equal to minus sine inverse x. Okay. Similarly, we can write it for cos inverse of minus x is equal to pi minus cos inverse of x. That's exactly what we do when we have a negative value of x on the right hand side. That is, the number is negative. So what we'll have to do is we'll have to subtract the theta value, pi minus the theta value. Then it will give me the cos inverse of minus x. Okay, this is your cos. Then we can write that for tan. So tan, we'll say that this is the sixth one. Let's go to the seventh one. Now for all x belonging to R, okay, tan inverse of minus x is equal to minus tan inverse x. Means for all possible values of R, we can say that tan inverse of minus x is minus tan inverse x. Okay, then the next one, if x is a positive value, if mod of x is greater than equal to 1, okay, then we can say that cosec inverse of minus x is equal to minus cosec inverse x. Okay. And similarly, if x value is positive and greater than 1, then sec inverse of minus x is equal to pi minus sec inverse of x. Okay. That is for cosec and sec. And now we're left with cot. So let's write the same for cot. So cot inverse of minus x is equal to pi minus cot inverse of x. Okay. Now let's go to the next identity that we have to write. So let's go to the ninth one. If minus 1 less than equal to x less than equal to 1, then we can say that sine inverse of x plus cos inverse of x is equal to pi by 2. Okay. Similarly, we have a property for tan. So how do we write that? We put as 10 for all x belonging to R. Okay. We can say that tan inverse of x plus cot inverse of x is equal to pi by 2. Okay. And for x greater than 1, cosec inverse of x plus sec inverse of x is equal to pi by 2. Okay. So what are the values when x lies between minus 1 and 1? Sin inverse plus cos inverse is pi by 2. For all x belonging to R, tan inverse plus cot inverse is pi by 2. And for x greater than or equal to 1, cosec inverse is, cosec inverse plus sec inverse is pi by 2. Okay. Let's go to the next property. So if x is greater than 0, y is greater than 0 and x into y is less than 1, then we can say that then tan of, or sorry, tan inverse of x plus tan inverse of y. Okay. Remember we had a formula for tan of a plus tan of b. This is similar to that. So it will be tan inverse of bracket x plus y upon 1 minus xy. Okay. This is the property for tan only when x is and y is greater than 0 and xy is less than 1. Okay, so these are the properties that we should know before we start with the next exercise. Please let us begin with exercise 3.3 now. Okay, we'll go with the first question. So it says find the principal values. I'm taking the first one only, sine inverse of half. So now we'll first find out the actual value, that is sine of pi by 6, sine of 30 is half, right? Now we have to check whether they lie between the range and domain. Okay. So first let us see whether our domain is satisfied. So we can say that pi by 6, okay, belongs to or lies between minus pi by 2 and pi by 2, right? Between 90 and minus 90, 30, yes, lies between them, and half belongs to minus 1 comma 1, right? Lies between minus 1 and 1. Therefore, the inverse exists, and therefore we write that sine inverse of half is equal to pi by 6. Okay. Now, does pi by 6 fall into the principal range 30, or does it fall into the range that they have given? Yes, it does. So, therefore, principal solution will be of, if we write sine inverse of half is equal to pi by 6. Okay. This is the first one. Let's go to the second one. Second one says cosec inverse of 2. So again, first we'll see whether we're getting cosec theta as x. That is, cosec of what will give me 2. That is pi by 3. Sorry, not pi by 3, pi by 6. Because sine 30 is half, so cosec 30 will be 2. So cosec of pi by 6 will give me 2. Let us check whether it's lying in the cosec inverse range. So 2 belongs to, you can say, r minus, so infinity minus minus 1 comma 1, and pi by 6. So pi by 6 belongs to, what has to be excluded? Uh, 0 has to be excluded. So minus pi by 2 and pi by 2, yes, it lies between the 2, and minus 0. This is their range value. So is this true? So yes, it is lying. So we can say that cosec inverse exists, and cosec inverse of 2 is equal to pi by 6, and it is the principal solution. Okay. I'll just move on to one more sum, and then we can go to the next question. So the sixth question I'm taking, it is cos inverse of 1 minus half. Cos inverse of a negative value. Now first, how do we get a negative value for cos? Then we'll check for cos inverse. Cos of what will give me minus half is what I have to find out, right? So let us go to the previous exercise when we had begun with principal solution. So what we would do was, cos of what gives me half first? So cos of pi by 3 is half. But I want minus half, so I'll write it as cos of pi minus pi by 3, okay, is equal to minus cos pi by 3. Okay, now what is cos pi minus pi by 3? It is cos of 3 minus 1, 2 pi by 3, okay, is equal to, what is minus cos pi by 3? It is minus half, right? So now I have got the theta value, which will give me minus half, right? So we'll fill in this 2 pi by 3 over here. So this step will become cos of 2 pi by 3 is equal to minus half. Now let us check whether it's lying in your range and domain. So minus half belongs to minus 1 comma 1, and 2 pi by 3 does belong to 0 comma pi, right? So it is falling in the range and domain of our cos function. So the cos inverse exists. So cos inverse of minus half is equal to 2 pi by 3. Okay, this is our question 1. Now we'll move on to question 2. Okay, so question 2, let us go to the first one. It says evaluate, and what is that? Tan inverse of 1, okay, plus cos inverse of half plus sine inverse of half. What we have to do is we have to just find out their values and add them. So tan inverse of first let us find the tan value, which will give me 1. So that is pi by 4. So tan inverse of 1 is equal to pi by 4. Okay. Then again we'll do cos over here. So cos of what is half? That is cos of 60 is half. That is pi by 3 is half. So cos inverse of half is equal to pi by 3. Okay. Similarly, sine of what is half? Sine of 30, that is pi by 6, is equal to half. Therefore, sine inverse of half is equal to pi by 6, right? So let us add in all this. So we'll have pi by 4 plus pi by 3 plus pi by 6. Okay, we'll take in the LCM, we get 12. That is 3 plus 4, that is 7 plus 2, 9 pi. Okay, and 3 and 4. So we have 3 pi by 4 as the answer for this. Okay, let's go to the third one now. There's simple sums, question 2. Third one, tan inverse of root 3 minus sec inverse of minus 2. Okay, again, how do we begin? So when do we get tan as root 3? First, we'll find out the theta value of that. So tan of 60, because sin 60 is root 3 by 2. So tan of 60 means pi by 3, we get root 3. So tan inverse of root 3 is equal to pi by 3. Okay, and sec inverse of 2. So first let's find the positive value. Sec of what is 2? So we have cos of 60 is half. So sec of 60 will be 2. 60 is pi by 3. Okay, but we want minus 2. So we write sec of pi minus pi by 3, okay, is equal to minus sec pi by 3. Okay, now what is this? Sec of 2 pi by 3 is equal to minus 2. Therefore, sec inverse of minus 2 now is equal to 2 pi by 3. Substitute in the equation on top. We'll have pi by 3 minus 2 pi by 3. Okay, so you're left with minus pi by 3 as the answer. Okay, so this is question 2. Okay, now let's go to question 3. It says prove the following. Okay, in the next session, we'll go to question 3 of prove the following trigonometric equations that they have given. Okay, I hope we are clear with question 1 and 2 of exercise 3.3. If you have any doubts in the explanation, do write to me. Thank you very much.